Hi, my name's Daniel Rogge. I'm one of the people here at Tormach working on PathPilot, and I'd like to talk to you today about some of the conversational features in the PathPilot mill interface. So we've got a number of tabs along the front here. You'll notice one of them says Conversational. These are kind of the ways to program the machine to do tasks that are simple enough that you don't have to go to CAD CAM. Don't have to design the thing in a solid modeling system and then do the toolpath design in CAM. If you click on Conversational, you'll see we have several tabs up along the top here. So we've got ways to generate facing G-code, profiles, circular and rectangular, pockets. We can do drilling and tapping straight here, including bolt hole circle patterns, thread milling, and then we've got an engraving tab. And I'm going to go through these relatively quickly, but I'll talk one by one about the features associated with each one of them, and we'll do a couple examples. So I guess we'll just start in order here. It's the facing tab. It's for facing off stock. These entry fields are common to all of them, so we can give this a title here, face 1 or just, widget, whatever we want to call it. It'll take your work offset, that, G54 through G59.3, all the different work offsets you could be using. Some people call that your zeros, right? Takes the tool number. I have a fly cutter as tool 10 here. And you'll notice when I type in tool 10, it'll take the tool table, the diameter from the tool table, and it gives me kind of a hint. It's saying, look, 70% step over on that tool is 1.75 inches. It'll take in a feed rate. It'll take in a Z feed rate that's separate. So that's the, when you hit the clear plane, the Z feed, the motion from the clear plane to the Z start happens at the Z feed rate. And here we have a clear plane. That would be, if you have toe clamps or anything you need to skip over, a clear plane would be where you'd program that height above the height of the workpiece. And then on the specific tabs, this is specific to the facing routine. We just specify the geometry. This would be the geometry of the workpiece. I typically program my part 0 at the rear left-hand corner of the workpiece. So I've got X start of 0. So if I hit enter, it'll transfer over to this next value. And hitting enter to get between fields is nice, but it also helps us validate the value you put in. So if I mean to type in 3.25 and I accidentally type in some nonsense like that and hit enter, we'll see an error message and it'll say, oh, invalid X value, sure. So we'll go ahead and let's just say our stock is 3 inches long and maybe 3 by 2. So here we have a Y end of -2 inches. Step over here, we already mentioned we've got this fly cutter in here, but let's say we had something smaller, just like a, half-inch end mill. I think, tool 2, maybe a half-inch end mill. Y start at 0, we'll do a Y end of -2, so we've got something that's 3 inches long by 2 inches deep. Y start, I'll face this down to Z start, I'll face this down to a Z end value of 0, so Y start will be at 100th of the part. We'll just do it in one pass. Let's say step over of, pretend we're using a half-inch tool, so the tool path looks interesting here. We have step over of 1/2 inch. We can go ahead and post this thing to the file here. It asks us to name it. We can save it in a different folder here. I'm going to go ahead and save it under my name. We've got my folder and save. And you'll see it goes ahead and generates the tool path here. So there's our tool path. We can see the extents. It actually goes a little bit further because what it wants to do here is it wants to enter the workpiece in this Z direction, so it's not just plunging directly into the workpiece. So it actually offsets a bit to plunge in at a safe distance. And then it goes ahead and cuts the part. Right? So that's face. Let's go over to profile here. We'll do some examples here. A little bit busier page, but same idea. We assume that we've got some piece of stock, some raw material that we're starting with. In this case, I'll go ahead and assume it was the same thing. So X start of 0 for the stock, X end of 3, Y start of 0, Y end of -2. And then it allows me to define a profile, and I'm saying we've got something that's roughly a 1/4 inch smaller, 0.25, 2.75, and I could put a radius on this if I want. And if you're used to any kind of CAD/CAM software, some of this will be fairly straightforward. We could do circular profiles as well. Let's just show you an example of a rectangular profile. And we do our best to create a constant tool length engagement, constant tool engagement tool path here. So you'll see when we post this thing here, we're taking a fairly constant tool engagement we've got here at the corners. You can see it takes an extra little cut so it gets the radius in there correctly. And if we want, we can do this in all one pass, or we could in fact go back in here and say that our Z depth of cut would be, 0.25. Go ahead and repost this. I'll just override it. And now we'll see it does this in 2 separate passes. Pocket is fairly similar, both rectangular and circular pockets. I'll just give you an idea here what the tool path looks like here. And it'll try to spiral in and get your circular pocket. Once again, it's great for simple geometry. If you have something very complicated, obviously you'll want to go to CAD/CAM, but this is an easy way to get going. We've got a drill tap pattern here. This is some values left in here before I delete this. Clear all of these. We could either enter in values by hand, so 0, 0, 1, 0, that kind of thing. Or we can do a circular pattern generation. So here I've got, maybe 5 holes that I want. Let's say it's 6 holes. This gives you a start angle. This is off of the 3 o'clock position. It gives you the diameter of the bolt hole circle in the center. This is a nice little feature here. A lot of times you'll want to use a spotting drill before you drill, so you can specify a spotting tool number. I don't know, tool 11 happens to be my spotting drill. And we'll say we'll go 100 thou deep with the spotting tool. And then the rest of this is all your strategy for drilling. So a peck drill at 100 thou, Z start, Z end, stuff like that. I can go ahead and we'll call this drill circle. And we'll go ahead and post this. We'll see what we get. So there it is. There's our little drill circle, 6 holes. If you look at the pattern tab, you'll see that the values that are used for those 6 holes have been pre-populated in the pattern, which is kind of nice because we can go to do a tap and retain those, right? So this would be a way for us to tap. We can tap with a precunior tapping head. We can tap with just our standard tension compression tapping head. You'll notice if we're tapping, let's say, a 1/4 20 hole, 20 threads per inch, it'll go ahead and change your pitch accordingly. Dwell here is for the tension compression tapping head. Some people like to tune it in, so we'll do a 0.2 second dwell. It basically says you'll over travel by a little bit. There's more information about dwell and tapping and tension compression in our tapping guidelines document. But you'll see there's a little note up here describing exactly what happens. The other nice thing about having this circular pattern populate this table is that the thread milling tab also uses this table. So thread milling, we can do external thread mills around a big circular boss, or we can do internal thread milling. And this is using a single point thread cutter here. And I don't know, let's say we're going to go ahead and do a 3/8/16. So we'll do those 6 holes that we made for drill circle. We'll go ahead and thread mill it. I'll call it thread circle or thread mill circle, whatever we want to call it. It does use the diameter from the tool table here, so to create the the proper tool path. So we definitely have to know, not sure what looks like tool 4 here has a pretty small diameter of 1/8 of an inch. I don't actually have a thread mill in the machine right now, but I'll use tool 4 so that the tool path looks somewhat appropriate. Then we'll go ahead and post this and take a look at what we get here. So here we've got, this is the thread milling. And you actually see there's multiple passes in here, right? And just to be clear, if if this tool 4 had a different diameter, it's like a 1-inch diameter tool, you wouldn't be doing a thread milling operation with that. You try to post that here, and it's going to give you an error. It's going to say, you know what, we can't thread mill a hole that's a 3/8 inch 16 fastener hole with a 1-inch tool, obviously. So this just wanted to show you here that thread milling page does assume that you've got the diameter of your thread mill properly entered in here. So there we go. There's our thread milling code. Last tab here is the engrave. So engraving tab, I could, Dan Montenegro is the videographer. Hi, Dan. You want to say hi?
Hi.
So we'll type in his name here, and we can choose the font. You can actually upload your own fonts in here. Any TrueType font should work. You can upload fonts on the File tab. If we look here, engraving fonts, just stuff that you bring in over from a USB drive will allow you to use your own TrueType fonts. But anyway, these are the fonts that come in the system here. So we specify a height of the text, I don't know, 1/2 inch high, and the lower left-hand corner here. And we can justify this in the center, justify it to the right, clear distance, depth of cut, all that stuff. We'll go ahead and call this engrave. My naming here isn't very creative. But in any event, that's what you get there with the engraving tab. One nice feature of the engraving tab here is that we can do serialization. So I might say serial number or something similar, and we can choose maybe something that looks a little fancier for serial number. And if I type a value in here for serial number start, let's just go ahead and say we'll start at 0. Actually, just to show you this, I'm going to start at 000, and there's a little distinction. If I go ahead and I post a file, we'll just overwrite that engrave code. Now it's going to say serial number. You don't see anything on the toolpath, but if I ran this code, it would engrave serial number 000 here. And then the next time I would run this code, it would engrave serial number 001. And then the next time 002. And so that allows you to do serialization. We do that through a macro. You actually look in the G code here. It's probably somewhere down at the bottom. G47 is our serial number macro, and it's going to read in the current value of that serial number, and you can assign that on this page relatively easy. Right now it's going to say the current serial number is 000, but if we ran this code a few times, we hovered over it, it would say current serial number is 011. If you want serial numbers with 5 digits, you could have it start at 14, for instance, right? But the number of leading zeros, the number of zeros, the total number you want in here would be specified by that. And if you just leave it empty, no serial number gets appended at all, right? So that's the entirety of the conversational. And then I'll give you an example of how you might stack different conversational files onto one another, right? So we know that we did this face thing here. Let's rename this something a little bit more original. Or say we're going to make some kind of race car trophy, right? Or whatever we're doing. And tool number 2 for this. And we'll go ahead and post this to the file. Sure, similar code that we've posted before. We'll go back and let's say we want to then cut out a profile that we faced the top off. Now we're going to cut a profile on it. We could go ahead and append a file, and we could choose race car trophy. Just append that to the file. And now we have the two together. You see it's superimposed on top of one another. Our first face and then our profile. Now we can certainly go back. We could put a pocket in the middle of this thing here. So we would then append this to the file. Right? So there's our pocket right in the middle. And you're probably getting the idea here that we could take anything and we could go ahead and append this to the file. And that that'll give us that the composite file here. So that's an overview of the conversational tabs in PathPilot and the milling interface. The idea here is, you're not going to be able to handle everything that you'll want to machine with this, but the simpler tasks, like facing off a part or squaring up some stock, should be much faster to do in conversational than in CAD/CAM. And there are a couple things like thread milling and engraving that can be really clunky in CAD/CAM. That's very nice to be able to do right here at the interface. We're constantly looking for ways to improve this, so if you have any suggestions, please feel free to email us at pathpilot@tormach.com. Thank you so much.